Welcome to our webinar, Lab Informatics Roundtable, Real Insights to Shape Your Search for a Science-Aware Solution. Today, we'll take a closer look at what it means to be science-aware and provide real-life insights to guide your solution search. With that, let's get started. We're going to begin with a brief introduction, and then we'll introduce our speakers and get right into our panel questions. Today's webinar will take a roundtable format that is guided by key questions related to the search for a science-aware lab informatics platform. The adoption of a proper solution for lab informatics has never been more important, particularly given the heightened complexity found in today's labs. This rise in complexity is really multifaceted, and it includes more complex molecules, operational processes, reporting requirements, and data sets. The lab informatics platform a laboratory chooses will inevitably have a significant impact on the efficiency of its workflows, the strengths of its science, and the quality of life for its science. Those are pretty high stakes, and they really underscore the importance of getting this decision right. So how can your lab ensure it's making the right platform choice? Well, just like science is about asking questions, so too is the solution search. By asking the right questions, scientists are better equipped to find a solution that addresses their needs. And there are a number of questions that are listed on the screen here. Like, how long will solution implementation take? Or how can I search, visualize, and analyze data in this platform? Questions like these will enable you to gauge whether a platform you're choosing can meet your scientific needs and avoid any unexpected issues down the line. So similarly, today's agenda will also center around key questions. Our goal is to unpack some of the key considerations in a solution search with the help of a few subject matter experts on the Sapio team. With that, I'd like to introduce our three panelists, Kevin Kramer, Andrew Wyatt, and Rob Brown. Kevin, would you like to introduce yourself?
Absolutely. Hi, this is Kevin Kramer. I'm the CEO and Chief Technology Officer at Sapio.
And we'll pass it over to Andrew.
Hi, I'm Andrew Wyatt. I'm Sapio's Chief Growth Officer and General Manager for EMEA.
Now, Rob, would you like to introduce yourself?
Yeah, hi, my name's Rob Brown. I am Sapio's Product Marketing Manager.
Thank you, everyone. With that, let's dive into our questions. Okay, so first question today is, how do scientists and lab decision makers know when it's time for a solution switch? Kevin, do you want to get us started?
Sure. We haven't seen any one reason that people make a switch, but there's usually several different things we hear. Most frequently, I think the inflexibility of the application that they currently have is a driver for change. And we've seen this happen with solutions that people only own 1 year, where they see after a year of trying to get the solution to do what they want, that they've been unable to do it. And then there's people who've had solutions for 10, 15 years that finally reach their limits in terms of flexibility and the ability to adapt the application to their needs. So they start to look and make a change. There could be other reasons like time to move to a web-based solution or cloud-based solution instead of a thick client or client server application. But I think most commonly it's lack of flexibility in the current application.
Yeah, I think I'd agree with that, Kevin. I would say it's time to switch when the system you're using becomes more complex than the science is actually using to support. Many scientists nowadays feel they need to become a computer scientist in order to get their work done, and that really shouldn't be the case. The technology should be there in support of the science, not against it.
All really good points. Thanks, everyone. So for our next question, I'd love to hear your thoughts on the biggest areas that solutions leave scientists wanting. Andrew, do you want to start us?
Sure. I think the big issue that we see, and Kevin's alluded to this before, is inflexibility, and that's a big one. What you see is that systems have been built in a siloed fashion in the past, and that really restricts how the science can be performed. So much of what we're doing today is based around how teams work on particular science problems. And really, you need to make sure that you've engaged those individuals in the process and that's really critical moving forward.
Yeah, I think that we started as a machine learning company, and that's still, constantly in our mind is thinking about positioning yourself to make sense of your data. And so we always think about the data. And I think that not having easy access to either the data that's in the system or being able to easily and efficiently collect data into the system, and then have the data accessible in a usable way so that you can find the data you want to find easily, and then visualize the data in the system, and then analyze the data in the system where it resides. I think this is something that's been lacking historically. And we think that verticalizing on the platform so that you can do all these key functions in one place is the most efficient way to accelerate the R&D process.
Thanks for your insights. A lot of relevant info for today's scientists. So now I'd like to take a closer look at Sapio specifically. So Sapio's platform is science aware. What does that mean, and why should it matter to today's scientists?
Well, of course, having a true platform is important. So this is a kind of a technical aspect where you have this kind of uber flexibility that allows for velocity of getting in place tracking of data and process quickly. But once you get beyond that, you have to be supporting the science. And this means having a system that actually understands sciencey things. So to be able to work with small molecules all the way from design to synthesis, and then assessing synthesized compounds. On the large molecule side, to be able to do CRISPR design work, as well as plasmid design, PCR primer design, et cetera. So these are very scientific topics. And then also to bring in analytics that makes sense for life sciences. An example in our solution is to be able to analyze flow cytometry data. So this is it's a bit of an art, not necessarily a scientific process. So we need to present tools and capabilities that make it easy to analyze flow data within our platform.
Thank you. I'd like to briefly walk through the markers that make up the AWARE acronym. So Kevin, could you run us through those at a high level?
Sure. So we have access. This is the ability to get to the data, right? As I mentioned earlier. Workflow is W, so that's tracking process. I mean, labs are process driven. So particularly on the bench itself, you're going to follow a particular protocol, and the ability to model that and track it quickly in the system is very important. And then A for analytics. So we need to be able to make sense of the data. And if you're having to move data between many different applications to address all these concerns, it's highly inefficient, error prone, and costly to support. Reusability is a big aspect of our product, to be able to create components that are reusable throughout the application, whether you're doing ELN type experimental work or pre-configured workflows. We have all these reusable components in the platform. And then experience. So we want the user experience to be as smooth and seamless and easy as possible. And one way to do that is to avoid having many different tools, that everything you need to do, you can do in one place, and it's presented in a simple interface, making it easy for you to learn the system and get onboarded quickly.
Thanks for summarizing those, Kevin. So Rob, having been a scientist yourself, I'm curious which of those 5 markers you feel matter the most to today's laboratory decision makers.
I think it's really all about the workflow, right? So if you're going to be productive in the lab, you're going to follow some very sophisticated lab workflows. But what you actually need from the software is to reduce the complexity of these, not just add to them. So if you actually have workflows in the software that are really cumbersome, then that's when your progress is going to really start suffering. And the other key point about the workflows is you have to remember science is constantly evolving. So those workflows have to be really flexible, and the workflows have to be able to adapt to keep up with the rate of change of science, so that productivity kind of continues. I don't know, Andrew, what do you think about it?
Yeah, for me, it's experience. It comes down to experience. We have a whole generation who've been brought up on the web. They're used to great web experiences. Why is it that when they go into a lab, they suddenly have a compromised experience there. You want to make sure that, if you're familiar with Microsoft Office Online or the Google apps online, you don't leave those apps to go and chart your data elsewhere and then cut and paste it back in. That just provides barriers to entry, and it's not what people are used to. We really want to make sure that scientists can focus on the science and not have technology get in the way.
Really interesting perspective, Andrew. So our next question is, how would you say that modern science is really changing requirements for a lab informatics solution?
Let me take that one. So you have to remember there are some very, very specialist areas of science now. As science evolves, specialities grow. So things like NGS analysis, bioanalysis, bioprocessing. And it's not enough to take old systems and just retrofit to those. You have to have science that comes out of the box to really meet these new requirements.
Yeah, and I'll add that there's always new technology in the lab, equipment-wise, that's important. But I would say, coming back to the data again, that people are realizing the importance of the data more than ever. That's because we have some amazing new analytical tools in terms of deep learning neural networks, for example, that are likely to revolutionize the life sciences R&D process. But in order to use those, you need to have the proper data all together in one place that you can feed into these algorithms. So it comes back to a unified platform covering both ELN and LIMS, so you don't have data in 2 or more applications, and then the ability to collect, search, and access that data in a way that it's usable for these interesting new analytical capabilities.
And just to follow up on Kevin's point, the other thing is the scientific process. It's not just the scientific processes that are changing. The actual entity types themselves that are changing. In the beginning, it was small molecule therapeutics. Then it was small molecules and antibodies. Now there's a huge variety of kind of these mixed modality types, chemically modified oligos, ADCs, and you have to have the flexibility to even define new data types in the system and then to capture the experiments based on them. The other point Kevin made, just to follow up on, is just the sheer volume of data, right? All of the automation that's going on in labs now is a real problem without a true platform for scientists to keep up. So, as an example, what if in your HTS lab, you can generate data in a week on the automation, but it then takes scientists 3 months to analyze that data. So every week they're 3 months further behind. We really need the platform and the processing to solve the data problem so that scientists can just come in and look at the results, understand what the experiment meant, make a decision, and move on.
Really good dialogue around that question, and clearly a lot of exciting things happening in the scientific landscape, which can be enabled by the right platform. We talked about questions and their role in the solution search a little bit earlier. What are the most important questions that a laboratory decision maker should be asking a vendor?
I'll start on that one. I think that it's important to get the vendors out of their comfort zone, and that means getting them beyond their canned demo, which might look very appealing. You're always going to want to have the system be personalized to your needs, and the best way to assess whether the system can do that is to have the vendor actually show how that would happen, how the system is configured. If it's truly a low-code, no-code platform, that should be demonstrable. And they should be able to show you how you're going to configure a workflow, even a complex one. How are you going to implement business rules with no code? Make the vendor show this to you. And then make them show how you're able to access the data. If we want to search across the whole system to find certain data based on certain criteria, how do we do that? Can a novice user do that? Or do we need to be coding SQL or get technical people involved? And then if we want to visualize the data, and analyze the data, how do we do that? Can we do it inside the platform? Is it approachable for a regular scientist to know how to do it? So I think these are the important things to be asking to make sure you're making the right decision for something that's going to last for a long time, not 1 or 2 years, but 10, 20 years down the road.
Yeah, I think my favorite question to ask is, how long is it going to take to implement? And are you going to turn my scientists into coders as a result? So much of what I've seen through implementation is you need an army of coders to put a solution live. And that really leaves a business with a headache when it comes to operational support and upgrades moving forward, because every line of code is probably going to struggle when you do a software upgrade underneath. And it just means it incredibly difficult to operationally manage and maintain moving forward. More to the point, it means your scientists are moving, again, further away from their job, which is science.
Thank you, Kevin and Andrew. So to close us out today, do you have any advice for scientists who might be in the solution search right now?
I'll start with that one. I think the biggest advice is just don't settle. Choose a platform that's going to meet all of your requirements straight out of the gate, and choose a platform that's going to delight the users, because they're going to spend their lives in it, right? So for example, if you're looking for an NGS solution, this is especially for you. That platform's an investment in the future of your lab and your results. So just make sure it's really up to the job.
Yeah, I'd reiterate that. You need to keep an eye on the future. Picking a solution that's just going to solve the problem at hand today really means you're limiting your opportunities to ensure that as the science moves forward, as your business moves forward, you can adapt and change and meet future needs.
Definitely, very good points. I think that scientists are probably inherently curious, and they should be curious about the solution they're going to ultimately be using. How do I do my job? How do I do it better? How's the solution going to support me in getting data into the system, modeling and designing entities, finding data, and analyzing the data? You should be curious about how the system is going to support this and how it can adapt to changes over time. So I think that don't restrict yourself to the vendor's canned solution. Just ask all the questions that you can think about in terms of what you think you may want. And also let the vendor lead you in places you might not have thought about in terms of functions and features that you might not have contemplated, but actually will end up being important for you. And let them take you into some of those areas so you can fully consider all the applications capabilities that you're looking at.
Really helpful insights and advice that scientists can apply actively to their solution search right away. So thank you so much, Kevin, Andrew, and Rob, for taking the time today to answer these questions. This is the conclusion of our webinar. If you have any specific follow-up questions, feel free to reach out at the email or phone number listed here on the slide. In addition, we'd like to share our companion guide to this webinar, which is a science-aware approach to lab informatics. In it, we'll elaborate more on the science-aware markers that we mentioned here today in greater detail, and it also provides a lot of insight on some of the additional topics we've explored together. You can download it for free using the QR code on the screen. Thank you all again for joining us today. Whether you're actively searching for a new platform or you're considering making the switch from your existing solution, I hope you found our content interesting and enjoy the rest of your week.